So the first one here, they're saying in the equation, HF plus H2O, giving us the hydronium ion and the fluoride ion, okay? And then they're saying which of the following here is true, okay? So we can see that in this case, this HF here is donating a proton, or is donating the hydrogen, the water. No wonder here you have added another H here. No wonder you have H3O plus, okay? So this guy here is donating a proton, okay? So this one is an acid because it's donating a what? A proton. And then this guy here is its conjugate. It's okay. So we are saying HF is an acid because it's donating a proton. And then this guy here that is left, okay, after this acid donates a proton there is what is known as the conjugate base. So here the correct option was C, okay? HF is an acid and F minus is its conjugate base. What is left after the hydrogen has been donated, okay? So the answer here is C. And then number two, they're saying in the Bronsted system, a base is defined as, we all know that a base is just a what? A proton acceptor. Okay, that's a base. An acid is a proton donor, and then a base is a proton acceptor. It accepts the proton from the acid. Okay, so here the correct answer is D. And then number three, they're saying a 0.1 molar solution of weak acid HX, okay, is 0.059% ionizable. Okay, evaluate the Ka or calculate the Ka. So we know that if this is a weak acid, okay, and it dissociates into whatever it dissociates into, okay, for us to find the Ka value, okay, for us to find the Ka value, we are going to say that this will be equals to, when this dissociates, you have hydrogen ions, okay, multiplied by the X ions, okay, and then we divide all this by the constitution of this guy here, which is HX, okay, so this is what we are going to do here. So for us to apply this formula to find this Ka, we need to find the constitution of H, okay, and that constitution of H, we're going to equate it to the constitution of this, okay? So since here they're saying it's 0.059% ionizable, we know that the degree of ionization, we can calculate it by this formula. Let me write it here, okay? So degree of ionization, we know we can calculate it by this formula. Okay, we say the concentration of the ions that have dissociated, the hydrogen ions, divided by the concentration of the whole acid like this. This is the formula that we use to find the degree of what? Ionization. But in this case, we've been given that the degree of ionization, this one here, the DOI, degree of ionization, we've been given that it's what? 0.059%. Okay, so we have to equate this to this guy in order to find this guy, because we know we have the value for this guy. Okay, the concentration of HA was given as the concentration of this acid. We were given that it is 0.1 like that molar. Okay, so we also have the degree of ionization. We also have the concentration of this. So it would be difficult for us to find the concentration of these ions. So we are going to write this 0.059 divided by 1,000 and divided by 100 because it's a percent. Then it's equals to the concentration of the H plus divided by the concentration of the acid, okay, which is okay, so this is what we have, and then the concentration of this guy is 0.1. So we want to find the concentration of this. So we are just going to say 0.1 multiplied by all this is equals to the concentration of this. So we are going to say H plus is equals to, okay, this guy 0.1 multiplied by 0.059. I think network kicked me out of the meeting. Let me share my screen. Okay, so what was I saying before it cuts now? Okay, so I was saying this, we have to find the concentration of these guys here, the hydrogen ions. So just get your calculator and punch this value. Okay? So the concentration of the hydrogen ions will be equals to this multiplied by this. Okay, so you just get your calculator and punch it. You should get, okay, so I'm getting, I'm going to write my answer in scientific form. I'm getting 5.9 multiplied by 10 to the power minus 5 molar. So this is my concentration of the what? Of the H plus. Okay. And then since now we have the concentration of the H plus, okay, and we also have the concentrations of HX. Okay, we can be able to find the Ka value. Okay, we can be able to find the Ka value. So the acid that we have was this, remember, AX, and then this dissociates to H plus, K plus X minus like this. So what do we do to find the value of the Ka? Well, we're going to say Ka is equals to, okay, the product. So we are going to have the concentration of hydrogens multiplied by the concentration of this X, which is just the conjugate base, divided by the concentration of the HX, okay? So now, the concentration of this guy here, the H, the X here, is the same concentration as the concentration of the what? The hydrogen ions. So on top there, we're going to have this guy multiplied by itself times 2. So it's the same as we are squaring it, right? So we're going to get Ka is equals to, we have 5.9 multiplied by 10 to the power minus 5. And then we are multiplying this by itself. So we're going to say squared is divided by the concentration of the HX. Concentration of the HX is what? 0.1. Okay, so when we punch this into the calculator, okay, Ka is equals to, when I punch this, let me punch it, 5.9 multiplied by 10 to the power 5 to the power 2, okay, divided by 0.1. Okay, so I'm getting 3.5 multiplied by 10 to the power minus 8. Okay, so I'm getting my Ka value as this value here. Okay, so that's how you get your Ka. Okay, so you come here, you find your 3.5 here. So the correct option there was D. Okay, so if there are no questions there, I'll go to question 4. Question 4, we've been given the pH of the solution is 4.8. What is the concentration of the hydroxide ions in this solution? So from this pH, we first have to calculate the pOH. And then that pOH, okay, it can help us to find the concentration of this guy here. So this is what we are going to do, okay? So we are going to say the pH. We all know that the pH is just equals to what? Or let me say, no, not the pH, but let me say this. It's the pH plus, okay, the pOH. We know that it should give you what? It should give you 14. Okay, so from this, we can find our pOH here. So this pH we've been given as 4.8 plus pOH is equals to what? To 14. So let's find the pOH. So pOH will just be equals to what? 14 minus 4.8. Okay, my network is bad today, guys. So bear with me. Yeah. So we have, okay, let's find the pOH here. Okay, so 14 minus 4.8, my calculator is giving me a 9.2. So this one here is my pOH, okay? And then once you have your pOH, you can calculate the concentration of this OH, okay? So we know that the pOH is just equals to what? Minus log, and then the concentration of the OH here, okay? So meaning we can use the properties of logs that we learned in math in order to find this answer, okay? So remember that mnemonic that I usually say, which is BAM, base to the power answer is equals to what is in the mid. So this is the answer here. And then the base here, we know that it's base 10. And then what is in the middle is just this OH. So it means the concentration of OH minus will just be equals to, okay, what is the base? So the base is 10, and then to the power P or H like that, okay? So it means the concentration of OH minus will just be equals to 10 to the power, what was the POH? It was 9.2. So we put 9.2 here. Then you punch on your calculator. What are you going to get? Okay, 10 to the power 9.2. You should get approximately 6.3 multiplied by 10 to the power minus 10 molar. Okay, so you go on your options and then you look for this answer. So if we go on our options, we see that this answer is on D. Okay, so D there was our correct option. Okay, and then let's go to number 5, which is a conceptual question. So you have to understand the topic, the buffers. Okay, you have to understand how the buffering system works. Okay, so here they're saying a buffered solution that contains 0.1 molar, okay, of acetic acid, okay, and 0.2 molar of sodium acetate, okay. Then they're saying which of the following statement is true. Okay, so they have given us this statement here. So we have to identify what we've been given. So we've been given an acid here, and we've been given a what? A salt. Okay, so this is sodium acetate, and then this one is the acetic acid. So what are we going to do with these things here? We are going to describe the effect of each one of these here. So if on A here, they're saying if a small amount of sodium hydroxide is added, the pH decreases very slightly. Okay, so what does the pH decreasing mean? It means it's becoming more acidic, right? Okay, it's becoming more acidic. So if the pH decreases, it means it's becoming more acidic. But look at what you're adding. You're adding a strong base to a buffer solution. So meaning it can become more acidic because you're adding a base. You expect that solution to also become what? More basic. So this one here is false. Okay. And then B, they're saying if sodium hydroxide is added, the hydroxide ions will react with these ions here. Now look, this is a negative charged ion, and even this one here is negatively charged. So they can't react. Okay, it doesn't make sense. For the reaction to happen, you need a positive charge and a negative charge. Okay, so even this one here is wrong. And then the correct answer here is C. Okay, but I'll come back to this data. Okay, let's look at D. So if hydrochloric acid is added, the hydrogen ions react with acetic acid. Now look, these as hydrogen ions, right? And then we said an acid is a proton donor. So this acid doesn't want these hydrogen ions, okay? So a reaction between these hydrogen ions and the acid cannot take place because this acid wants to get rid of this hydrogen that it has here. And then it's also given another hydrogen. It won't accept that hydrogen, okay? So there will be no reaction there. But the only answer that makes sense is this one here on C. Okay, so if you add a small amount of the acid, then the pH will decrease. That makes sense because if you add the acid, the pH will decrease and it will become what? More acidic. So the correct answer here is C. Okay, so learn to analyze like that if you are given a conceptual question. Here you're not solving, you're just understanding the concept and then applying. So C here is the correct answer. Okay. So if there are any questions, you're free to ask. Otherwise, I'll go to question 6. Okay, so question 6. Okay, you can ask.
So, I think there are some people, but there might go, there are some people, some voices coming behind you.
I can't get you. What you're saying? What are you saying?
I'm saying some people, but they have microphones on. There are some voices coming behind you as you're speaking. So you're not very clear.
Oh, let me try to mute everyone. Okay.
I can't hear anything. Is it only me or what?
Okay, so let's continue. I hope those background noises you can no longer get them. Okay, so I'm going to question 6. If I'm allowed to go to question 6. Okay, so question 6 now they're saying the conventional equilibrium constant, Kc, for the system below is, okay? So for you to find the Kc, or the equilibrium constant, whatever species that you are going to put here, they should be in either gaseous form or aqueous form. Immediate species is in solid form. You can't include it in the equilibrium constant, okay? So we see that this guy here, we can't include it in the formula for the equilibrium constant because it's in solid form. Even this guy here. And we know that the Kc is given by reactants on top and then the products, products on top and then reactants down. So here on the product side, we have a gas. So we're going to put that gas like that, okay? So we have the concentration of this gas, and then we are going to divide by the reactants. So do we have any reactants that are either in gaseous form or in aqueous form? We do not have any, okay? So the correct answer here will be C, okay? Correct answer here will be C. So always consider those in gaseous and in aqueous, okay? Those in solid, ignore them. All right, and then we have this guy here now. We have K, okay? So immediately you see K, it's the same as Kc when you're talking about the equilibrium constant. And then the Kp, which is the equilibrium constant in terms of the pressure, is always specified as Kp. But this one here, it can either be K or Kc. They're just the same. So they're saying the K is 0.04 for the system below, okay, at this temperature. And then they're saying evaluate Kp for the reaction at this same temperature here. Okay, so we have to apply that formula that you all know. We know that Kp, okay, is equals to the Kc, okay, and then we multiply this Kc by the gas constant R at that temperature, and then we are raising this to the power change in moles. So how do we get this change in moles here? We look at the product side and the reactant side, we get their moles, and then we subtract them. So if I can go back here, okay, so on the product side here, how many moles do we have? Okay, so the coefficient moles that we have here will be 1 plus 1. So we have 2, okay, on the product side. Then on the reactant side, we only have what? 1. So 2 minus 1, it will give us 1. So the change in N will just be equals to what? 1. Okay, so that's what we are going to put here, 1. And then this one here is the constant value, okay? We know that the gas constant is just 0.0821. And then the temperature, we have been given in degrees. We have to change it into kelvins, right? Okay, so kelvins is just equals to the same temperature that you have, and then plus 273, right? Remember this formula. So from this, I'm going to get, if I add them, I'm going to get 723. Okay, so this is my temperature. And then my R, we said it is 0.0821. And then this change, we said it is 1. And then our Kp, we were given as 0.04. So we're just going to place those now into the formula. So this will be equals to 0.04. And then inside these brackets, we're going to have 0.0821 multiplied by 723. And then we are saying to the power 1. Okay. So now multiply this guy with this guy. What are you getting? So you punch on your calculator. It's giving me a 2.4. Some number which is close to 2.4. Okay. So meaning the 2.4 is our answer. So you go on your options here. You check for 2.4, which is on C here. Okay. So the correct answer is C. And then we go to question 8. They're saying when a system A plus B, okay, which gives C plus D is at equilibrium. Okay, so when this system here is at equilibrium, which one of these is true? Okay, so the first one, they're saying the sum of the constitutions of A and B must equal the sum of the constitutions C and D. Okay, so this is not true. Okay, because the sum of these guys cannot be equal to the sum of these guys. Okay, it's just the rate at which the products are turning into reactants and the reactants are turning into products. That's the thing that is equal, but there are some, they are not equal. So this one here is not true. And then they're saying the forward reaction has stopped, not true. Okay, the reverse reaction has stopped, not true. So the correct answer here is C. Neither the forward nor the reverse reaction has stopped. They are just moving at the same rate. So meaning at the rate at which you are making products is the same rate at which you are making the reactants. Okay, and when we say that that system at equilibrium, okay, so the correct answer here will just be C. Okay, and then 9. Oh, they're saying what on 9? Okay, so on number 9, they're saying the equilibrium constant for the acid ionization of mercaptoethanol, which is given by this formula here, is 1.91 multiplied by 10 to the power minus 10. Okay, so what do we notice? We notice that this equilibrium constant is very small. Okay, because this 10 to the power minus 10 is a very small number, and then you are also multiplying it with 1.91. So it will be a very small number. So what statement is true if the equilibrium constant is a small number? So remember, the equilibrium constant is found by what? Products over reactants. So if this K is very small, then it means that you have more concentration of the what? The reactants. No wonder when you divide here, the fraction here becomes smaller, okay? Because you have a large concentration of the reactants, okay? And the concentration of this product will be smaller. So for example, if I have 1/100, okay, it means my K here will be very small. So meaning the reactants are a lot, the products are what? A few. So now let's look at this. So they're saying which of the following is true regarding this equilibrium? They're saying the reaction is product favored, which means there are more products, okay? We're saying no to this because of this explanation that I gave here. And then they're saying the reaction is reactant favored, okay? This is true because we have more reactants. No wonder this K value here is what? Is smaller. Okay, what about this one here? They're saying the equilibrium lies far to the right. So this means that the equilibrium is shifting to the right like that. But this is not the case because we have more reactants. So it means the reaction has to shift to the left like that. Okay, so this one here is not true. And then this one here, they're saying the equilibrium lies far to the left. This is true because we have more reactants. So meaning this reaction is producing a lot of reactant. So 2 and 4 are correct. Okay, so you come here, you see this answer on D. So D here will be the correct answer. Okay, and then number 10, they're saying increasing the temperature of an endothermic reaction results in, okay, so if a reaction is endothermic, it means it requires energy for it to what? To take place, okay? It absorbs energy. So the energy that it absorbs is treated as a reactant. So if I have a reactant A plus the reactant B, okay, plus the heat, okay, producing certain products here, and then I add more heat. If I add more heat, it means I'm increasing the temperature, right? So since this is an endothermic reaction, adding more heat, okay, is adding more reactants to this equation. So if you add more reactants, what happens according to the Chartier's principle? The equilibrium will shift to the left, okay, so that it balances the reaction. Okay, so as a result, more product will be formed. Okay, more product will be formed. So here, when you go here, which one will be your answer? Okay, so our answers here will just be what? A there, okay? More products will be formed because we are adding this reactant, okay? And as more product is being formed, it means these reactants here are being used, okay? So there'll be more products and fewer reactants. So the answer there will just be A.